In this video, I want to look at the addition rule for probability. The addition rule for probability says that the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. And let's see if we can understand this rule using a Venn diagram. So here I have my Venn diagram with A and B. So I'm going to start with the probability of A. That would be everything in this piece of the A circle, as well as what A and B share. Next, we have the probability of B. So that would be everything in the circle of just B, as well as what A and B share. And so now I can see that we've counted the intersection right here twice. So I'm going to remove one of my countings. So that's the reason I subtract out A intersect B. So I'm going to count everything in A, everything in B, and then remove everything I've double counted. Let's see if we can use this same idea to come up with a rule for three events, the probability of A union B union C. So let's start with the probability of A plus the probability of B plus the probability of C. To do the probability of A, we have this region here, this one, and this one here. So that would represent the probability of A. For the probability of B, we have the circle that's just B, A and B, A, B, C, and B and C. And then for the probability of C, we have the part of the circle that's just C, the part that's B and C, the part that's A and C, and the parts that's A, B, C. So we can see we counted this region between A and B twice. So we're going to subtract out A intersect B, as well as B intersect C, and A intersect C. So that's going to help us with all of our double counting here. So I've removed one of my countings of A intersect B. I've removed one of my countings of B intersect C. Do our best to try to erase one of those. And A intersects C. So I've done one of the intersections of A intersects C. And now we can see we're missing a region. So we then have to add back in A intersect B intersects C. I've actually completely removed it whenever I subtracted all of these intersections. So let's do some examples using these rules. In a certain community, 60% of families own a dog, 70% own a cat, and 50% own both a dog and a cat. If a family is selected at random, calculate the probability that the family owns a dog but not a cat. Let's try to set this up with a Venn diagram. So this is going to be my dog, this is going to be my cat. The entire D circle is 60%. The entire C circle is 70%. And we know that 50% own a dog and a cat, so that would be the overlap, 0.5. I want the probability that a family owns a dog but not a cat, so I want this region here. Well, we know the entire dog circle is 60%. I've already accounted for 50%, so this must be 0.1. So the probability that they own a dog but not a cat would be 0.1. Next, we want the probability that the family owns a cat but not a dog. So this time I want this region here. Well, I know that 70% own a cat, and I've already counted for 0.5 of this. So we would have 0.2 owns just a cat but not a dog. Finally, we want to calculate the probability that a family owns one of the two kinds of pets. So just a dog or just a cat, but not both of the kinds of pets. So we would add 0.1 plus 0.2 to get a total of probability of 0.3. You're playing a game that requires you to roll 2 dice. In order to win, you need at least one of the dice to be a 2, 3, or 4. What is the probability of winning? Well, in this case, we want the first dice to be a 2, 3, or 4, or the second dice to be a 2, 3, or 4. So I'm going to need to use my rule, the probability of winning on the first dice, the probability of winning on the second, and then we need to remove the probability of both since I would have double counted. If I just think of one die, a 2, 3, or 4, that's 3 options out of a total of 6. The same thing for the second one. So minus the probability I win on both. So if I think that through, that means rolling a 2, 2, a 2, 3, a 2, 4. I could roll a 3, 2, 3, 3, or 3, 4, or 4, 2, 4, 3, 4, 4. All of those would win me on both dice. So that's a total of 9, and when I roll 2 dice, I have a 36 different options for rolling the die. And if we work this out, we get 27 over 36, or 3/4. So I have a 3/4 chance of winning this game. Next, a person is selected at random from the population of Verizon wireless subscribers. We're going to let A be the event that the chosen subscriber has friends or family added to their plan, and B denote the event that the subscriber has unlimited text messaging. Extensive records suggest that the probability of A is 0.37, the probability of B is 0.23, and the probability of A union B is 0.47. I want to find the probability of A intersect B. My addition rule tells me the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. Well, we know A union B is 0.47. The probability of A is 0.37. B is 0.23. And then I don't know the intersection. This is what I'm trying to find. This gives us 0.47 is equal to 0.6 minus the probability of A intersect B. And then solving this equation gives us that the probability of A intersect B is 0.13. Let's consider the game where 2 dice, die A and die B, are rolled. We're going to say that die A wins and write A is greater than B if the outcome of rolling A is larger than the outcome of rolling B. If both rolls result in the same number, it's a tie. So I want to find the probability of a tie. Well, if I think this through, I have the probability of a tie being the chance we roll doubles. So we could have a 1, 1, 2, 2, 3, 3, etc. There are 6 possible doubles, 1 through 6. Rolling 2 dice, there are a total of 36 different outcomes. So there is a 1/6 chance of getting a tie in this game. This time, I have the same problem. I want to find the probability that die A wins. And rather than using a rule, we're going to think this through. There are 36 possible outcomes. We've just said that 6 of them result in a tie. So out of those, there are 30 that could result in either A winning or B winning. And we should feel pretty comfortable to say that this is going to be split half and half. So 15 would have A win, and 15 would have B win, since we're kind of splitting this thing right down the middle. So it'd be 15 over 36, or 5/12 way for A to win.